So thank you, guys. Thank you, everyone, for joining. Today's session is largely brought about because of the number of questions we've had from customers. The Smart CodeInsight piece came out in RAD Studio 12.2, so it's a couple of updates ago. It got a big update in 12.3 in the most recent version. But we had a surprising, well, maybe not surprising, but we had a number of customers say to us, well, I'd love to use that, but we can't. And we'll get in a second about why they couldn't. But they couldn't use it. And when one person said it, I explained and thought, oh, well, that's the end of that. But we had enough people ask that I thought, well, we should just do a webinar on it. So that's the point of today. So let me just get going here. As the little ticker across the bottom of the screen says, if you've got any questions during this, add them in the chat window. I'll keep an eye on that as we go through. As I said, for those of you who were here right from the start, when I started this little ramble, this is meant to be a very informal session. I've got a few slides, not too many. We'll go through them very quickly. Most of the time we'll spend in the IDE interacting with models, changing models, trying out different ones, giving you a feel for both how to switch between them, how to try out new models, but also give you a bit of visibility into how some of these models vary. So we'll spend most of the time doing that. So while I'm doing that, if you've got a question, just yell out and in the chat window. Don't yell out in your office or in your room. Just put it in the chat window, and I'll try and get to it while we're going. Okay. All right. So let me make sure I know how this new webinar software works, and we will get started. So let's just in case you're not aware, my name's Malcolm Groves from Code Partners. It's me that you're stuck with for the next, I don't know, 40 minutes or so as we talk about this stuff. And hopefully you're in the right place. What we're going to talk about is using local models with Smart CodeInsight, which, probably begs the question of what is Smart CodeInsight. Just bring that up there. So Smart CodeInsight is the AI coding assistance in RAD Studio. As I said a second ago, introduced in 12.2, quite a big update in 12.3. But it's both, that sort of chat interface that, probably a lot of people are used to with interacting with AI these days, but also in editor, right-click in the editor, and there's a bunch of things in there as well. We'll have a look at some of these. So that's what Smart CodeInsight is. Sorry, wrong window. I told you I was getting used to this new software. So if we have a look on this screen, no, it's not on that screen. It's on that screen. There we go. If you can see that, one of the value propositions, or one of the key differentiators maybe for Smart CodeInsight, is the fact that it is not bound to a particular model. Now, when I say model, really, I guess I could also say LLM. It's just that's a bit longer and trickier to say. But different AI models are available, whether that's GPT from as in ChatGPT, or Gemini from Google, that sort of thing. There's a bunch of them available. And Smart CodeInsight, unlike a lot of other IDE AI assistant features, lets you choose which one of these you want to use. Yeah, so that's kind of cool. And there's a bunch of, I guess, what you might call online models, things like GPT from OpenAI, or Gemini from Google, Claude from Anthropic. They're the three that are available out of the box for online models. And when I say online models, I guess what I'm talking about are models that are hosted by third parties that you can get API access to and start interacting with. So just as you can, we'll talk about this in a second, but just as you can interact with a model or an LLM through a chat window, like you've probably done in things like ChatGPT, you can also interact with them through an API, a REST API, actually. And so a bunch of different companies offer both API and chat access to their large models. Yeah. And the three that Smart CodeInsight supports out of the box are these, OpenAI, Google, and Anthropic. But interestingly, and the point of this webinar today, it also supports offline models through this thing called Olama. Now, Olama isn't a model itself. You can kind of think of it as a host or an application that will load, that you can use to load up a model definition yourself and run and then interact with. Yep. And it provides an API for you to access that local model. And by local, it might mean the same machine that you're running the IDE on, which is what I'll be doing today, running the IDE and the various models we'll interact with on this local machine. It could also mean on another server on your network, in your data center or under your desk or wherever your servers live. So that would also qualify as local. Or even it could be, you could be hosting it on like an EC2 instance or something in Amazon, but your own EC2 instance. The key point, I guess, is that it's not run and managed for you by some other company. It's yours. Yeah. And you control the what happens with the data in it and that kind of thing. Maybe we'll talk about that. So I guess the key thing, offline, meaning that, you could run it on your laptop with no connection to the internet and use it. And so there's some level of certainty about where the data goes. Okay. I keep saying out of the box. That's because all four of these, the models that are supported by Smart CodeInsight are actually implemented through the OpenTools API. So third parties can add more. You can add more if you want to. Dive in and implement the APIs, and you could have another tab show up next to these ones with whatever it is that you're trying to implement. Yeah. So I would hope that over time we'll see other ones added in there. Yeah. All right. So, but you might be asking, well, why do I care? Why would I go to all this trouble of running a model locally? Why wouldn't I just use Gemini or Claude or GPT or whatever? And that you can. That's totally fine. But this would be a super short webinar if that was the point. You can, and many people do, and I do occasionally. I have done, and I still do occasionally. I guess the point, though, is that I was about to say many people. There are a number of people. I don't know how many, but there are people for whom this is not possible. Yeah. And some of the reasons for this come down to, or the reasons that we've heard, one of them is data sovereignty. So, for example, here in Australia, certain industries that you work in, healthcare, other things, also certain government groups, have to ensure they're not allowed by regulation or even legislation in some cases for the data that they deal with to go offshore. It has to stay on within Australia. And so Gemini don't let you specify that I want to use, Google doesn't let you specify that you want to use Gemini in Australia on Australian servers, or OpenAI don't let you say I want to use ChatGPT but locally. So for many people that just rules them out. They can't do it. Another one, and these are going in order of the number of people that we see. So a few people mentioned the data sovereignty issue to us. More people mentioned concerns around IP protection. Yeah. If for a software company, even if you're a division within a company that isn't about software, but for a software group, their crown jewels is the source code. Yeah, that's what we do, and that's the thing that has value ultimately, or one of the things that has value is the IP that we've built up. Yeah, and in order to interact with an AI, you do need to, it does get visibility into some of your source code. Yeah. Depends what you're doing with it. It may be only at the method level, but if you're asking it to act on more of your code than just a particular method, then you're providing that source code to the model. Now, it's hard to know what OpenAI or Google or whatever do with the source code that you provide it when you're asking it questions. If you send it a unit and say, oh, can you explain what this class does or whatever, what happens to that source code? That some of them have made statements to say that, well, we don't train our models on the source code that our users provide it. Some of them haven't made comments like that, but ultimately you don't know what is happening to it. And so for some people don't care about that, which is valid. That's your choice. But some people really care about that and aren't prepared to share their proprietary source code with an external group. Perhaps not surprisingly, the largest objection we've heard from people about using ChatGPT or Gemini or whatever, these online models, is around cost. Because over time it does add up. It's a typical cloud hosted scenario. The sticker price looks good, but the more you use it and over time you start to realize that the bills get bigger and bigger. And I think we've done maybe half a dozen projects for people where we've integrated AI, LLMs into their applications. So not talking about the IDE here, but integrated into their applications. Most of those have been using local models, but one of them, the very first one we did, was actually using GPT from OpenAI. And they've continued to use it, but just recently, actually in the last month or 6 weeks, they've come back to us and asked us to start looking at how they can migrate off OpenAI to a local model like we're going to look at today for their application, not for the IDE. But their reason for doing it is not data sovereignty. They're not IP protection. They're not impacted by either of those things. It's cost. It started out interesting. Their customers who use their software, which we've integrated the AI into, have started using it more and more, and the bills have started getting bigger and bigger to the point now where they want to see if it's viable to host it themselves and save some money. Yeah. So there could be other reasons. These are the main ones we hear. Again, if these things don't apply to you, then great. Use OpenAI, use Google, not a problem. I don't have a dog in this race. All right. One last thing to talk about before we get rid of the slides and start doing stuff is this. When you're talking about models, you'll see references to number of parameters. Yeah, and now I don't really want to get into the weeds talking about what a parameter is and that sort of thing. But I do want to make a couple of points about number of parameters. If we just have a look, this is not a timeline, I should say here. This is I don't know what you call it. It's a line of showing you low numbers of parameters through to high numbers of parameters. It's not about dates or time when these things happened. Back in 2018, I think GPT-1 from OpenAI launched with 117 million, call it round figures, 100 million parameters. Yep. And this was astonishing at the time. I know someone who's involved in the AI industry, and prior to this happening, he was saying almost everybody in the industry assumed that hundreds of millions of parameters was just, was decades away. Couldn't be done. They had a large model, model at the time that they were super proud of, that was 200,000 parameters, and they would boast about how many parameters they had. And then a month later, after they were boasting about this, GPT-1 launched with over 100 million parameters. But that is now a tiny model, actually. GPT-2 a year later came out with 1.5 billion. So, rough maths, rough figures, 10 times more than 10 times increase. And then a year later was when GPT-3 hit, and it had 175 billion. GPT-4 has since come out with 1.76 trillion T. Yeah. So the number of parameters has just exploded to the point now, you'll see in a second, that the absolute latest models, what are often referred to as frontier models, the companies have stopped stopped disclosing how many parameters they have. Yeah, but why do you care? Why you care for two reasons. One, we'll talk about one of the reasons in a second, but a number of parameters has been a reasonable gauge for capabilities of the model. You know, in super general terms, and we'll talk about in a second about how this is not always true, but in super general terms, more parameters means a more capable model. Yeah. More, broader knowledge, that sort of thing. Certainly if you're talking about general purpose models, models where you want to ask a super wide range of questions to, from, I don't know, have a discussion with it about Don Bradman's impact on cricket, through to scone recipes, through to, I don't know, whatever else you can think of. When you're talking about really broad knowledge domains, then their number of parameters can very much translate into, more parameters is better. Yeah. But for our purposes, something interesting started to happen. Gemma came out with 2 billion. Gemma was Google's open source, and I'm doing quotes around that one. We'll talk about why in a second. Was their open source model. Companies started releasing open models, and making them available for download. So this is where we started to see people able to run local models. Originally, they started doing them largely for other researchers. So a researcher wouldn't have to create their model from scratch. They could take Gemma or Mixtral and use that as a base on which to build their particular trained model on top of. Yeah. But they were, Gemma was 2 billion initially. Mixtral was 140 billion. And then something interesting happened, and this is the one of the key points. Llama 3.1. Llama's the model that comes from Meta, the Facebook, Instagram company. Llama 3.1 came out, and it had multiple sized models: 2 billion parameters, 70 billion parameters, 405 billion parameters. That was all Llama 3.1. Yeah. They may not have been the first, but they were certainly the biggest model to start coming out with, the first sort of larger model to start coming out with, or I shouldn't say large, the first well-known model from a large company to come out with multiple sizes. And now this is really common, as you'll see in a second. So this became good because you could say, well, let me compare what a 2 billion parameter model performs like versus a 70 billion parameter model. Yeah. And now there's many, many more sizes in between. Yeah. And as I mentioned before, these days, the large companies have stopped disclosing the number of parameters they have. Yeah. So you could think, as I mentioned before, that, oh, well, more must be better. Yeah. But that's not entirely true. The frontier models, these large models, have limitations. Yeah. They are generally trying to be general purpose tools. Sorry, I use general a lot in that sentence. They have a limitation, or they can have a limitation, when it comes to specialized domains. Yeah, that old saying about jack of all trades, master of none, that's very much applicable for most of these large models. Yeah, they can get you to that you can ask a super broad range of questions and get, answers. But if you start drilling deep into a sort of a niche area or a specialized domain, then you can start to run aground pretty quickly. Yeah. They also have a problem with recency, or currency, maybe I should say. They have a cutoff date for when their training was done, and anything that happened after that, they don't have the knowledge to talk about. Yeah. So that's a problem, especially if you're talking about using these things in your business and you want to have it be aware of more recent information. This is a problem. Now, obviously, there's ways around this. You can use things like RAG, that sort of stuff, which we might touch on later on. But still, if you go to OpenAI and ask it about the last weekend's election here in Australia, don't rely on that being able to give you an accurate answer. And that's where this third problem comes in, is overconfidence. An incorrect, for these large models, these general purpose models, an incorrect answer is usually delivered with the exact same level of confidence that a correct answer is delivered. So there's no indication. Some models are now starting to give you, to be able to give you indicators to say, I'm not so sure about this bit. But in general, a model will just try and bluff its way through. And say, and so you're left trying to work out if this very confident answer it's given you is correct or not. If you've heard people talk about models hallucinating, that's exactly what this is. So when models start hallucinating, they start making up answers. But the problem is, you don't know they're making them up. It's delivered with the same certainty that a fact is. So what do we do? Well, what you can, if you think about it, if you're trying to have a model that serves a real specialized domain, which we are here, if you think about it, we don't need a model that can talk about cricket or scone recipes. We have a very narrow domain that we want this model in Smart CodeInsight to focus on, and that domain that we want it to focus on is Delphi or C-Builder programming. So we don't need it to know all that other stuff. So we don't need it to be hundreds of billions of parameters in size, but we do know it to have a depth of knowledge. We do need it to have a depth of knowledge about Delphi or C++ builder programming. We do want it to be really up to date. If we go and change one of the libraries that we rely on, or if there's a new version of, I don't know, DUnit comes out or whatever it is that we are dependent on, we want the model to be aware of that. We don't want it giving us out-of-date information because it was trained 3 years ago or something. And we do want it to be delivering us good information. The overconfidence thing, the thing with the overconfidence is you never get away from it entirely, but you can, with a local model and a small model, you can adjust the parameters to turn down some of the hallucination. So, you probably want an answer of, I don't know, rather than making up an answer and trying to bluff its way through. So what we've found is, especially for business applications, and really Smart CodeInsight is a business application for LLMs, is that, size doesn't actually matter. In a focused domain, a small model that's been well trained and fine-tuned on the domain can actually easily outperform a large general purpose model. It won't for general knowledge, but for a specific domain, if your domain is the data in your medical practice management software or your legal practice management software, or in our case, our source code and RAD Studio and the libraries that we're using, a small, well-trained model can actually run rings around OpenAI or Gemini or those sorts of things. Anyway, that'll do us for talking. Let's get to doing. So how are we going to, let me just jump back here. How are we going to set this up? Well, we've already sort of talked about one of the things that we need, which we're going to, if you remember, we talked about how we're going to use Ollama to do local, we're going to do direct inference on a local model. So we're going to need Ollama installed. Now, let me change screens again. Okay, you can go to ollama.com. I'll put the link up on the screen, and there's a QR code you can scan there if you want to, but it's just olama.com. You can go there, hit the download button. It's available for a bunch of different platforms, Linux, Mac OS, and Windows. Run it, install it. Okay, the install is pretty simple. There's no hard questions that it asks you. But what you end up with is, let me just bring it up. In the case of Windows, you end up with a command line tool called Olama. Yeah. If you've done any work with Docker, it'll feel very familiar. In fact, I think one of the founders of the Olama project was an ex-Docker person, so it borrows a lot of the way of working with Docker. Yep. And what Olama, this command line tool, does is it does a couple of things. It's, as I said before, it's the local host that will load and run your models for you, and it also exposes a quite lightweight API that you can call. Yeah, and it's this API that RAD Studio has been set up to speak to. Yeah. So once we've got Olama installed, we can go back to that website and we can start looking through models that we might want to use. Yeah. So let's have a look. You can see there's a bunch in here. You might have heard of DeepSeek R1. That was popular around Christmas time when it came out that the Chinese company behind this had managed to train it much more cheaply than some of the other models. But you come here, you get a bit of a description, and then you see these blue boxes across here. These are all the different sizes, the different numbers of parameters. So different size models that are available. So remember I said that when Llama 3.1 came out, it was kind of one of the first big ones to provide 3 different sizes. Well, you can see here DeepSeek R1 is providing versions at the top end at 671 billion parameters, all the way down to a smaller model, which is 1.5 billion. Yeah, and you can see some parameters involved. There's a README here, but the key thing you want to do is you can drop down and select which one you want to try. So let's say you wanted to try, I don't know, the 8 billion parameter version. Yeah, it then gives you a command that you can copy to run at that command prompt. Yeah. Now, I won't do this one. Let me grab the small one just because it'll download faster. If we copy that and come over to my command prompt and paste it in, okay, Olama run DeepSeek-R1. That's the DeepSeek-R1 is the name of the model, and then the colon, and then the variant or the size, in this case, 1.5B. Yep. So if you hit that, you can see it starts to download it. Yeah. Now, I probably won't let this run all the way through because it's not very interesting watching this chug all the way through this. But basically, if I show you, I've cancelled out of that, but if I show you, if I instead do Olama list, we can see the different models that I've already downloaded. Yep. And you can see there's a couple of, there's Llama 3.1, Llama 3.2, Quencoder, Starcoder, whatever. We can have a look at some others later on that you might want to play with. And so if instead I'll run one of those, one that I've already downloaded. So let's do Llama 3.2. And actually, I should need to say run in front of that. After the download had happened, this is what you would see. It would come up with this prompt saying send a message. Yep. And in fact, this is letting you chat immediately with the model. It's not a very nice chat interface, but you can. So you can say, tell me a dad joke. Okay, and it replies. So you can have a chat with it. Yeah. Now, you wouldn't really want to do this. There are, if you want to download these models and have more of a ChatGPT experience, there are other open source projects, like there's one called Open Web UI that you can download to give you like a proper web-based chat interface like you used to with ChatGPT. But if you put in /exit, it takes you out of that chat interface, but the model is still running. If we say Olama PS to show you all the models that you have running. We can see there's Llama 3.2, sorry, not Olama, Llama 3.2. It's running, it's 4 gigabytes in size. You can see it's 100% running on the GPU. Yeah, we'll talk about that a bit more in a second. And it's going to keep running until 4 minutes from now. And that timer, that's the default. You can set it up to stay running permanently. But by default, it will, every time you interact with it, it will, if it's not running, it will load it. It'll keep it in there until it's had 5 minutes of inactivity, and then it'll shut it down for you. Yep. So let's just come back to this bit here. Notice that it's saying 100% GPU. What's that all about? Well, models, LLMs, are much happier running on GPU than CPU. They can run on CPU, but they'll run quite slowly. And so ideally, you want to be able to run your model 100% in your GPU memory. So if we have a look in the Task Manager here, this machine that I'm on is not a particularly, it's not like a gaming machine that has a super fancy GPU in it. It does have a GPU, but as you can see down the bottom here, it's GPU with 12 gigabytes of memory on the GPU, and it has shared GPU memory, so it has the ability to use the normal RAM on my machine as a result, if it runs out here. But you can see that model that we've loaded, which was 4 gig in size, is running entirely in the GPU memory. Yep. And you can see when we asked it a question, it spiked. We'll see in a second when we get it to do some stuff in the IDE, we'll see the GPU usage spike. We'll see the memory go up. But ideally, for best performance, you want all or a very high percentage of your model to run in the GPU's memory. Yeah. Now, so this does bring in one requirement for running models locally. You need to balance how much hardware you've got versus which model you choose. You know, to go back to Olama, we could grab that 671 billion parameter version of DeepSeek. But if you have a look, it's 404 gigabyte in size. My GPU has, what did I say? 12 gig of memory. So the vast bulk of this is going to run on the CPU. Well, it probably won't even run, to be honest. But even if we went with the 70 billion model, the vast bulk of it is going to run on the CPU, and it's going to be achingly slow. Yeah. And how that will show to you is when you ask it a question, you know, you go and make a cup of coffee and wait for the answer to come back. Yeah. So this is the balance you have to make. How much hardware have I got, in particular GPU memory, versus what size of model I want, you know? So this is why, as I was talking before, finding a smaller model, like a 14 billion model, for example, and then fine-tuning it, training it on data, fine-tuning it for your specialized domain, A, lets you run it on smaller hardware, but B, can often result in a better result for your niche domain than a large model that hasn't been fine-tuned. Yeah. Okay. So there's lots more stuff you can do at the command prompt with Olama, and we'll come back to some later on. But let me just stop that. I don't have to stop the model, but I will, because there's something I want to show you. So I'll say Olama stop Llama 3.2. Now, you might be wondering, well, hang on, Olama and Llama, are these connected somehow? Can Olama only run Llama models? No. Like I said, Llama 3.1 was kind of one of the early models to provide multiple versions. And so initially, the Olama project was about helping you run Llama easily locally. It's now obviously expanded out beyond just Llama. Yep. So I've just told it to stop that model, and if we do PS again, you can see it's not running. Yeah. All right. So let's bring up Delphi or CBuilder. Yep. In this particular case, it's Delphi. So if we go into Tools Options and come down to inside the IDE section, we come down to Smart CodeInsight. Here is that screen that we were looking at before. Yeah. And you can see there's ChatGPT, there's Gemini, there's Claude, and here is Olama. Yeah. Now, all you really need to do to point RAD Studio, once you've got Olama installed and you've downloaded a model, and it's, well, it doesn't even have to be running, but you've downloaded a model, make sure it's come in here, enable it, put in the URL to the machine where Olama is running. Like I said, in this particular case, it's localhost, yeah, but it doesn't have to be. It can be somewhere on the local network, or even, you know, on a EC2 instance or something like that. And then the port by default is 11434. Yeah, you can change that, but by default it's 11434. So if you put in and if you can actually if you forget that what it is, the best way that I've found to get it, and it's a weird way, is to say Olama help. One of the commands, in this case PS, but I think it happens on all of them. And if you put in the help statement, it tells you the details about the help. And then down the bottom, it tells you that if you want to override the IP address for the Olama server, you can set this environment variable, but the default is localhost or 127.0.0.1.11.434. Yep. There's probably an easier way to do it. I have never found out what it is. But anyway, 11.434. And then if you drop down this model list, I don't think 12.2 does this, but 12.3 certainly. If you drop down the model list, it talks to Olama and finds out all of the models that you have downloaded. Yeah. So if you have a look at that list versus the list when we go Olama list, you can see we've got StarCoder, DeepSeek, Qwen, and then 2 versions of Llama. And here we've got StarCoder, DeepSeek, Qwen, and 2 versions of Llama. Yeah. You can just select one. I think on this list is a little more useful. It tells you the different sizes. So why don't we start with this Llama 3.1, this 4.9 gig model. Yeah, not very big. And then that'll let us look what happens when you go to a smaller one, and also look what happens when you go to a bigger one. Yeah. So that's all you need to do, is select the model that you'd like to use. Yeah. You can also distinguish between which, maybe you want to use ChatGPT or Gemini for the chat window in RAD Studio, and then use Olama for the editor AI features. Yeah, it's up to you. In this case, we've got them set both to Olama. Say that, click Save, and then at its simplest level, you can come in here and right-click to Smart CodeInsight and go AI Chat. Yeah. Now, I'll just, before I do this, let me show you the task manager. We can see our GPUs. It's jumping up and down a little bit, but it's sitting around that mark. Let me go and ask Olama the same question again. Tell me a dad joke. Press the button. While that's coming back, let's see what happens in here. We can start to see our GPU memory usage start to go up. Yeah. Well, it might have actually already answered. Maybe that's why we're... Oh, yes. There we go. It has already answered. But the other thing to notice is that if you remember, when I did Olama PS, we had no model running. Yeah. Whereas if I do it now, we have that Llama 3.2 model running. So RAD Studio, if the model, all it needs you to do is download the model. It doesn't need you to start it. Yeah. If it's already running, then it'll use it. But if you haven't started it, it will start it for you and then interact with it. So you might see, if it's not already running and you try to use the Smart CodeInsight features, you might see a slight delay on that first one while it starts the model. And then after that, you won't get as long a delay because it's using the model that's already running. Make sense? Cool. And obviously, if you've got if you're using OpenAI as well or Gemini, they'll show up in this list, and you can choose which one you want to ask. Okay. Now, let's get rid of that for a second. Okay, let me add a couple of components here. I just want to set up a little scenario, and I'm going to ask the same question to multiple different models. Oh, hang on, let me just check. It looks like there is a question in the chat window. Let me see. If you're developing on a VM, okay. If you're developing on a VM, is it best to install Ollama, I assume, on the VM or on the host? It depends. If you can expose, if the VM can have access to your GPU, if you can expose the GPU to the VM, then there's no issue running Ollama on the VM as well. Ollama doesn't use an awful lot of RAM and CPU. It's well, unless you're using a model so big that it bleeds out onto the CPU. But it does what it uses in most cases, and in best scenario, is the GPU. So as long as you can expose your GPU on your machine, on the host machine, through to the VM, then no problem. Otherwise, what we see, not so much for developers necessarily, but for if you're using, like for our customers where we've integrated models into their Delphi applications rather than Delphi itself, they typically are running a model on a shared machine. So maybe all of their users are all pointing back to a separate server that's running running Ollama and the model. Yeah, cool. Okay, so let's put a couple of items in here. This is going to be a sorry, you can see I'm using a smaller screen for this. So let's put in here 1, 2. I don't know. I'm making this up as I go. Okay, so why I've done 4 as a number will become clear in a second. All right, so let's do that, and let's add a button. All right. So let's go back into our code, and I'll bring up that chat window again. And what I'm going to do is say, write me some Delphi code to remove items from a list box that are not numbers. So this is the same question that I'm going to ask multiple different models, and we'll critique some of the results we get. Yeah. Now remember, this is quite a small model that we're using here. This was I think 4-point-something billion parameters. Llama 3.1, 3.2 we're using. So let's run this and see what we get back. Obviously, you can dock this window if you want to, but let's see what we get. I'll leave it undocked just so I can have a better layout. So here's what it's suggesting. Using Delphi's listbox and edit controls. Interesting. I didn't say anything about an edit, but that's fine. Along with the t-strings component. Wow, okay. To filter out non-numeric values from your list box. Let's see what it's actually suggesting we do. It's created an isNumeric function. Well, actually, why am I explaining this to you? Hopefully, it's explained it to us. Yes, down the bottom here. In this example, the isNumeric function checks whether a given string is numeric by looking for valid digits. Oh, that's an interesting approach. So let's go and have a look at it. Oh, it's using pos to look through the string to see if it's between, see if I is greater than 1. So if the position is greater than 1, or the item in the string is minus Wow, that's a okay. I don't like its approach, but anyway, that was the point. I was showing you a very small model, and then we'll look at a large model in a minute and see. But anyway, let's roll with this. I'd hate to see this in a code review, but anyway, and then it gives us a button click event, which walks through, gets the first listbox one.item list. Listbox T-listbox doesn't have an item list property, does it? Anyway, let's trust it. I don't trust it, but anyway, let's trust it and put it in the IDE and see what we get. Okay. What did I copy? I copied everything. So at this point, you're probably thinking, wow, why would I use this feature? Which is a fair statement. But trust me, it's the model we've chosen, not the not the Smart CodeInsight feature. So let's have a look. So we've got our button click one click. Interesting. Anyway, you can see immediately we've got a bunch of problems. I don't even think it doesn't know what listbox 1 is. Why? What's listbox called? Okay. This is all just weird. Oh, this is form 1 and my form's called form 2. Okay, that's not the AI's fault. Let's do that. Let's go back here. It's probably missing the declaration, is it? Yeah. Anyway, let's put this in here, but I think we can see that this is pretty poor solution. Let's get rid of form 2. Okay. Still lots of problems, okay? Doesn't know what item list is, so it doesn't seem to know how to iterate a list box or how to access the items in a list box. And then it just grabs the first value. Does it ever actually get the next value? No. Yeah, so this is way off. This is hallucinating. Yep. I couldn't have come up with a better example of an AI hallucinating. If you look at the information it gave us, it was supremely confident. It didn't say at any point, "Oh, not sure how to do this." It was like, "Here you go. This is how it works," and this is not at all how it works. Yeah. So let's do something. Hopefully, this will be a little bit interesting. Let's go back into our options here. And let's change our model. Instead of that one, let's go to a bigger model. I downloaded one. Actually, I've used Quencoder quite a bit. So we were just using a 5 billion parameter or a 5 gigabyte model. Why don't we try, let's go to Quencoder. Yeah. So let's go in here and just select Quencoder instead. Okay. Now, if we remember, what's running is still Llama 3.2. Yeah. But we don't need to stop that ourselves. If we just go in here and ask it basically well, we could ask it the same question. Let's do that, actually. No, before we do that, let's come over here and select this procedure. Let me use one of the other features. Did I copy too much? Okay. Let's use one of the other features in Smart CodeInsight, but we're using it, remember, with a different model now. So instead of going to AI chat, if I just say find bugs, if we flip across, I want to show you a couple of things. If we flip across here and see what's running, we'll now see that Llama 3.2 model isn't running in Llama anymore, but Quen 2.5 Coder is. And if we go over to my task manager, we should see that now we're using, because it's a larger model, we're using much more of my GPU memory. Yep. We're using, approaching 11 gigabyte of my 12 gigabytes here. We're still, we're not still. I was going to say we're still running entirely on the GPU. Actually, if you look back here in the Llama PS command, 87% of the model is running on GPU, 13% of it is running on CPU. So we may very well see this performing quite slowly. And in fact, if we go back to Smart CodeInsight, you can see we're still waiting for the AI to respond. And now it has. But the main reason for that is because we've chosen a model too big for our hardware. Yeah. We can only fit 87% of that model in there. Yeah. So we'll choose another one in a second, but let's see what it's done for us. So it's looked through that code and it's identified a few things. Okay. It's saying that we didn't in the for loop. That's in the button click event. So down here, let me get that out of the way. In this for loop, we haven't got I declared. Yeah, that's fair. That is one of the problems. So, and then it gives us a fix for it. Incorrect use of the isNumeric function. Good. This one's smart enough to recognize that this isNumeric function is not standard. So it's AIs make me crack up sometimes. So it's smart enough to realize that we're not using a standard function to test whether this is numeric or not, but it's too dumb to realize what we should be using instead. It's basically saying, okay, if you want to follow this procedure of checking the individual characters in the string, you should use char in set. Yeah, which at one level might be right, but there's a much easier way, and it hasn't identified that for us. Okay, so yeah, this one's not getting a great mark. Use of float type. Okay, code uses the float type, which is not a built-in Delphi type. It seems you might be trying to use the single, double, or extended types. Okay, handling non-numeric strings. Okay. Okay, so you can see it's gone through, and here's a summary of the fixes it's suggesting that we do. But still, I'm not a big fan of this solution. So let's change out again. Let's try, not Quencoder. Let's try one of these other models. Maybe StarCoder. If we just quickly jump across to, remember, you can go to find all these models on here. So if we see StarCoder 2, that's the one we were just looking at. There's 3, 7, and 15 billion size models. This one that we're using is the 15 billion. Okay. So that's that one. You see a few details about it, but you can also see what it is. And often these are other models, like, I don't know about this one, but maybe Llama, for example, that have been trained on more coding specific information. Yep. So there's a bit more information in here, but let's try that one out. Okay. So we'll try StarCoder instead. And this time I'll save it and I'll actually say to it, I'll ask it the question again. Okay, write me some Delphi code that removes items from a list box that are not numbers. Let's see what we get. Actually, while this is running, let's again go and check how much of our model is running in the GPU. Okay, possibly because I'm also streaming the webinar from here, that the webinar software is taking some of the GPU, because normally this one fits entirely in my GPU. But anyway, that's fine. Yep, we can see, oh, that seems to be, we're getting close to the max on our GPU memory. We can see it's now using StarCoder, which is the one we asked, and it has come back with an answer. So let's have a look at the answer it's given us. Okay. It's got a form, list box, button, procedure. That's all good. Oh, that's begin if not list box item equals -1. I don't even know what that one's doing. Let me ask it to go further. That was really confusing. Can you give me another example? And this is, oh, okay. Demo gods are against me. I might be pushing the limits on my memory here. So let's just restart. Okay, that's come up on the wrong screen. Let me come across. Okay. Let's just check that my Smart CodeInsight is still pointing at StarCoder. Okay. Let's do this again. I'll comment that out. Comment that out. We don't want any of that rubbish. Could have just commented the lot. Okay, and let's go in one last time. Show me some okay. So that'll be explaining the slowness. What have we got? Wow, T-panel on pane event. Okay, so I guess if I wanted to show you an example of hallucination, this would have been a good one. Let me jump straight to the one that usually performs quite well for me. Okay, one last time. Demo is not cooperating. Show me some Delphi code to remove all non-numeric items from a, I'll give it a T list box this time, so we're a bit more specific. Well, it's probably having to load DeepSeek Coder, I imagine. DeepSeek Coder, yeah, there we go. Again, not all fitting in my GPU. Yeah, I think next time if I do this, I'll have to somehow stream it from a different machine so that the model gets all of the GPU. That might explain why we're getting weird hallucinatory answers compared to when I did a practice run. Okay, so let's have a look. Let's go through the brief explanation. The remove non-numeric items procedure takes a list box as an argument. Okay, different approach. It iterates through the items in the list from the last item to the first using a for loop with a down to clause. Okay, so when I was going through the run through of this, the practice run, what I found is a lot of the models, they didn't have the problems we saw today, but I suspect that's because they don't have access to as much of the GPU memory. But a lot of them walked from 0 to count -1, yep, which obviously is a problem if you're going to be removing items because your count is no longer accurate as soon as you've removed one. This model consistently gets this right. So it's one of the sort of indicators for me that it's a little bit more useful. For each item, it retrieves the text. So let's check that first. For I equals listbox item. So listbox is added in as a parameter. Listbox.items.count. It's also figured out the correct property name. To count -1 down to 0. Excellent. It's doing it in reverse order. It's grabbing that item text. If not, excellent. It's also using try string to int. Yeah. So rather than coming up with some weird homegrown way to tell if it's a number or not, it's passing in item text. It does still have a bug, which we'll talk about in a second. But anyway, let's push on. check using try string to int. The item is not numeric, it removes it. Okay, and you can call it like this. So this is a lot better. It's not, I wouldn't go so far as to say it's necessarily good, but it's better. Yeah, so let's copy this into the IDE itself and let's try using it. I'll stick that over there out of the way. Let's put that there, missing the, I didn't copy the semicolon. Okay, I'll make it part of, rather than a standalone method, I'll make it part of the class. Okay, excellent. We have one error in here. Try string to int. There is no overloaded version of try string to int. Went away too quick. That can be called with these arguments. Okay, that's interesting. So let's use find bugs to see if the same model can find its own mistake, and you'd be surprised. Often it can, even though it was not smart enough to avoid the mistake in the first time, it was smart enough to find it, which, you know, to be fair, I'm like that too sometimes. So a little bit slow because we're not running entirely on the GPU. But let's wait for it to analyze the code and find all the bugs that it can. Let's just jump across to the task manager and see. Yeah, you can see our GPU's slogging away pretty heavily. And also a lot of that slowdown comes from having to reach off the GPU to the machine RAM rather than the local RAM on the local memory on the GPU itself. All right, so here we go. Has it found it? Please. Okay. Variable typo in try string to int. In the condition using I instead of item text. Aha, it has found one of the problems. Okay. No, that's not actually the problem, is it? Oops. What does try string to int expect? That wasn't the problem I was expecting. Yes, that's all right. So this first bug that it's found is not the one that that I was expecting it to find. Okay, so it hasn't actually found the problem. That's interesting. So you and I can probably tell a couple of problems here. First off, what does try string to int do? It tries to convert the value in item text into a number. Yeah. Catches the exception if it's not. So the exception doesn't escape from try string to int. Returns a Boolean depending on whether it was a number or it wasn't, whether it's successfully converted or not. But this parameter here is an out parameter. This is where it wants to give you back the converted value. Okay. Now, dangerously, it's trying to use the loop index as the out value. So really what we want to do is maybe put in here value, switch this one out for value. Okay, errors go away, and then we can probably put in the button click event and call it. Yeah, let's just quickly do that just so that we can really see if this thing works. Let's call remove, what's it called, non-numeric, and we'll pass in list box 1. Okay, and let's run it. Oop, it's come up on a different screen. Let me bring it across. Okay, so it's removed all the ones that were not numeric. Okay, that's not really the interesting point. So what time is it? So it's 1:15. So we've been going for a little while, but my main point is not to say you should use this particular model or this other particular model. Yeah. My main point was to show you both how to set up Ollama and how to play with different models and figure out which ones you like. Now, I was a little bit hamstrung in this because I didn't realize that my streaming software would grab some of the GPU memory. So I apologize for that, but you obviously won't be streaming this when you do it. So have a look. What I would suggest is have a look how much GPU memory you've got. Come over to Ollama, maybe search on Coda. Okay, that's, or Code, actually, maybe not Code, Coda. Search on Code. You'll find a bunch of different models you can use here. Some really weird looking ones. Other ones, this one's organized by popular. You can see how old they are. And you can see how many parameters they have. Once you've played with a few, you'll start to get a feel for, okay, my GPU, I probably shouldn't look at parameter counts greater than this amount. Yeah, it's not always true. You know, there's different techniques that people use to be able to squeeze more parameters into less memory. But as a rule, with this sort of GPU on this machine, I usually am topping out around 10, 12 billion parameters. Yeah. Have a look and play with them. Yeah. Now, there's a few questions coming in, and they're actually on one of the topics I wanted to talk about. So let me flip back to here. There's a few questions coming up saying, okay, like this one from Shane, how do you train the model and improve it? How do you further train this model? Does it learn automatically along the way? These are exactly the right questions. Yep. So first off, all of these models are these models at the moment are pre-trained. Yeah. If you come in and have a look at a few of them, they'll come down here, you can have a look and they'll tell you details about how they were trained and what sort of data they were trained on. Yeah. But they're kind of, if you download them and use them like we've been doing, there is no further training involved. Now, so that's a good starting place, but the value that we've seen, we haven't done it in Smart CodeInsight yet. That's one of the projects I'm working on at the moment. But in the applications that we've done for people where we're integrating LLMs into their business applications, that's where you can get big jumps in capabilities, where you can train your models on say in this case, training the models on both your source code and also the source code for libraries that you use. Like maybe you use Spring for D. Is that what it's called? Yeah, Spring for D. Maybe you use DUnit X. Maybe you know all of these libraries that you use, or even maybe you use the Canopka controls. Yeah, being able to point the model. It's not as simple as this, but being able to point the model at your source code and your source code you're dependent on and train it on that as well. That's where the big value comes in. So if that's something that you'd be interested in seeing another session on, let me know. Like I said, it's a project, a personal time project that I'm working on at the moment to train up models on, to make it easy to train up a model on, source code, Delphi source code that you are using in your application. If that's something you'd like to see a separate session on, let me know. That's a bit outside the scope of this session. This one was really about setting up Ollama, playing with different models, trying it out, that sort of thing. I do realize that the other thing that I didn't do, and I didn't intend to do, was show you all of the features of Smart CodeInsight. That wasn't what this was about. If you do want to see more about what Smart CodeInsight can do, there's a 5-minute sort of overview video there, I think of Marco Cantu, going through showing off the different features of Smart CodeInsight. So you can use that one as well. But again, this session wasn't about showing you how to use Smart CodeInsight. It was about showing you how to use local models. Yeah. Couple of other final things. I just wanted to make people aware that the ADUG Symposium is on this week. This is the ADUG, Australian Delphi User Group, their yearly conference. It's been going for 26 years now, with a little gap, I think 1 year for COVID. It's both in person and online. So even if you're not able to be in Melbourne, like I will be fortunate enough to be, even if you're not able to be there, it is streamed online. There's a bunch of great speakers this year: Marco, Primosh, another Marco, and Brian Watson. So yeah, have a look on there. Great organisation, great event, full day event. So lots of useful information. Okay, so I hope that was useful. If you've got more questions, I'm happy to sit here and deal with them, but I realise it's lunchtime in some places and you probably want to go and eat. If you've got other questions that you want to ask but not on the chat in here, you can get in contact with us here, that link or the QR code. Happy to answer questions or whatever that way, or dump them into the chat window. And we can deal with them here. So if you need to drop off, totally understand. Thank you for joining. But otherwise, yes, have a great day. And I'll stay here for a little while and answer any other questions that people have got. Let me have a look in the questions. Yes, a couple of people saying that they'd be keen to know more about training models. So yes, we can definitely line that up once I finish my personal project to get it working. I mean, it's working at the moment, but it's not easy. So I'd like to get it to the point where it's very easy, where you can just basically provide a list of either repos or folders, parent folders for your source code, and point it at it. So yes, all right, I'll finish that off, make it easier, and then we'll do another session. I'll hang around. As I said, I'll hang around, wait for any final questions, but otherwise, have a fantastic day. We'll send out a link to the replay if you want to rewatch some pieces. Even though the demo didn't go exactly how I wanted to, I hope it got the point across to you. Yeah, we'll hopefully see you on a future webinar. All right. Thank you, guys.